Finishing up from yesterday. We already checked the solution of negative 3. What happened when we plugged negative 3 in?
We got 0.
Where?
What?
Where did we get 0 at? Where we can't have it.
The denominator.
The denominator. Negative 3 made my denominator, some of my denominator 0, which I can't have, correct? So negative 3 is an extraneous solution, which means I can't have it as a regular solution. Now we're checking 3 halves to see if it does work. It gives me a true statement when I plug it in. So yesterday we plugged it in and we've got up to this point right here, correct?
Yeah.
So now today we're finishing it out, finishing up the notes. So I'm going to erase this top line up here. Okay, 6 divided by negative 3 halves. Anyone got a calculator? What is it? Negative 4. Over, I have 8 times 9 fourths. What does that give me? 18 over 9 fourths minus 9. Negative 27 over 4. Minus, what's 6 divided by 9 halves? Negative 4 over 3. Everyone okay with that? We're just simplifying each little step as we go. Erase down here now. Negative 4 equals, I've got 18 divided by negative 27 fourths. What does that give me? (18) divided by negative 27 fourths. Negative 8 over 3. Okay. So on the left I still have negative 4. Now I have negative 8 thirds minus 4 thirds. What does that give me? Negative 4. Does negative 4 equal negative 4?
Yeah.
Yes, it does. I get a true statement. So I know that 3 halves is a solution. Everyone okay with that? Questions on it?
No.
Can I move on? Okay, consider the function f of x equals 2 over x plus 3. Determine whether the inverse of f is a function, then find the inverse. So based on the original function, how do I tell if its inverse is a function? Why do you think I had you grab the graphing calculators?
Are we going to put it in our calculator?
Yeah, we're going to graph the original function. There's this thing called the horizontal line test. For the horizontal line test to work, if my horizontal line only hits one point at a time on the graph, then I know its inverse is a function. If it hits more than one point at a time, I know it's not a function. Okay? So be careful with how you type this in. I'll probably type it in like this. 2 divided by x plus 3 in parentheses. That's how I'm going to type it in my calculator. Type it in exactly like that. We're all typing it in. We're going to have some issues here, okay? You need to wake up. Wake up. Type this in your calculator. We're graphing it. Okay? 2 divided by x plus 3. And graph it. Type it in exactly like I have it written on the board. So here's our graph. It's coming in somewhere over here. Wait, I messed up. So your graph should look something similar to that, correct? You don't have to draw your graph on your paper. You can if you want. But that should be something similar to what your graph looks like, correct? It's just a rough sketch.
Yeah.
So, using our horizontal line test, remember this is an asymptote down here. This is a horizontal asymptote. This is a vertical asymptote. These lines are gradually getting closer and closer and closer to this x-axis. Do they ever touch it though? No, but they're gradually going closer and closer and closer, right? So they're never going to be just horizontal to the x-axis, is it? No. So will my horizontal line ever touch more than one point at a time? No. Since that has a slight slope to it, that's never going to touch more than one point at a time. So would you say the inverse is a function or not a function?
It is.
It is a function because it's only going to hit one point at a time. It's going to pass the horizontal line test. So I'd say, golly, I can't write. The inverse of f is a function because it passes the horizontal line test. I'm going to put HLT. So that's what I have to say first, because I'm determining whether the inverse of f is a function or not. So I'm saying it is a function because it passes my horizontal line test. Are there any questions on that? Remember, to tell if an inverse is a function or not, graph the original function, use your horizontal line test. Okay? Questions about that first part? Now I need to find the inverse. Does anyone remember how I find the inverse of a function? Yep. Switch x and y, and then what do I do from there? And solve for y. Very good. Is everyone okay if I erase my writing?
Yeah.
Everyone has it written down that needs it written down. So I'm trading out f of x for y. And I'm going to switch x and y's position within the equation. Just like that. Everyone okay with that? Switch x and y. Now I'm going to solve for y, and that will give me my inverse of the function f of x. So, what might be my first step here, trying to get y by itself? You're close with the second thing you said, but not quite.
Would you multiply 2/3?
No, not 2/3. What's the denominator of the fraction?
3.
What's the denominator of the fraction?
Y plus 3.
Y plus 3.
Yeah.
I'm going to multiply by y plus 3 to get rid of my fraction.
That's what Kyle said. I said just.
Yeah, he just said 3. I got to multiply by the whole denominator to get rid of that denominator. Okay? Whatever I do to one side, I have to do to the other. So I've got y plus 3 times x. And what's left on that right-hand side?
2.
2. We okay with that? Now I don't have to worry about fraction as of right now. It's going to be a lot easier to get y by itself now. Okay, what would be my next step? Getting y by itself.
Minus 3.
Nope. I'm not going to distribute, because, and here's why. I'm trying to get y by itself, correct? If I distribute through that, I'm going to get x times y. So I'd have to get rid of that x later on at some point. Whereas y doesn't have anything with it besides the plus 3, right? So x is being multiplied by that set of parentheses. So what could I do? Very good. I can divide both sides by x. So I get y plus 3 equals 2 over x. Is everyone okay with that? And y is now almost by itself. So my next step to get y by itself. Subtract 3 from both sides. So I get y equals 2 over x minus 3. And the book generally tends to call the inverse function g of x. So I'm going to say g of x equals 2 over x minus 3. So there's my inverse of f of x. Any questions how we got that? We okay with that? Okay, can I move on? Here's your assignment. Pages 400 to 401. Numbers 2 through 32 evens. 38 through 44 evens. 400 to 401. Numbers 2 through 32 evens. 38 through 44 evens. Are there any questions about my notes before I end the recording? If you don't finish this in class, you can use Desmos, the free online graphing calculator, or a graphing calculator if you need to determine whether the inverse of each of your functions is a function.